Hello, welcome to my channel. So today we are going to continue with the last topic on cardiovascular system, where we talk about fetal secretion and changes at birth. So let's now. So objectives, of course, we're just going to talk about the fetal. Then you all know that the fetal secretion is the secreting system of a fetus. That's why it's our last topic on the cardiovascular system. Because and the term usually refers the entire fetal placental secretion, which includes the umbilical cord and the blood vessels within the placenta that carry fetal blood. That's what we refer to as fetal circulation. So this is the structure we're talking about. So from the placenta, it goes and bypasses and goes into the inferior vena cava, then goes into the heart. After that, it's in the aorta, then it takes to the placenta. So that's what we are talking about today. Okay, so let's start. Before birth, the fetus obtains oxygen and nutrients from the mother through the placenta and the umbilical cord. Then the blood from the fetal heart, that is destined for the lungs, is shunted away from the lungs through a short vessel called the ductus arteriosus and returned to the aorta. When this shunt is open, it is said to be a patent ductus arteriosus, and it is a congenital heart disease, of course. Then the placenta is an organ that connects the developing fetus to the uterine wall to allow nutrients uptake, provides thermoregulation to the fetus, waste elimination, and gas exchange via the mother's blood supply. They have to fight against internal infection and produce hormones to support the pregnancy. For instance, progesterone can be is produced by the placenta after the 4th month of pregnancy. So this is how the placenta looks like. So this is the uterine wall. Then we have blood that is connecting to the this is the uterine wall from here. Then you have the chorionic villi that are embedded in the uterine wall. Then these are the uterine arteries, then uterine vein, and this is the maternal blood, and this is the chorion. Then the umbilical vein is here. Then you have the umbilical arteries. So the umbilical cord, we have one umbilical vein and two umbilical arteries. The umbilical vein is one, and the umbilical arteries are two. That is what we are referring to here. So this is the structure of the placenta. This is how it looks like. So we have the umbilical cord here, of the fetal artery, and we have the fetal vein. That's how the placenta looks like. Then you have the chorionic villi, then you have the maternal arteries, maternal veins, and the lacunae. Placenta. So the core concept behind the fetal secretion is that fetal hemoglobin has a higher affinity for oxygen than does adult hemoglobin, which allows a diffusion of oxygen from the mother's secretory system to the fetus. The secretory system of the mother is not directly connected to that of the fetus. So the placenta functions as the respiratory center for the fetus as well as the site of filtration for plasma nutrients and water, glucose, amino acids, vitamins, and inorganic salts freely diffuse across the placenta along with the oxygen. Then the umbilical arteries carry blood to the placenta, and the blood permeates the sponge-like material there. Then we have the oxygen which then diffuses from the placenta to the chorionic villus, an alveolus-like structure where it is then carried to the umbilical vein. That is what is going to happen. And then the special structures. So we have a connection between the right and the left atria, via the foramen ovale, and the connection between the truncus pulmonalis and the aorta via the ductus arterialis. Then the ductus venosus shunts most of the left umbilical vein blood flow directly to the inferior vena cava. Thus, it allows the oxygenated blood from the placenta to bypass the liver. Then you have the hypogastric arteries which enter the umbilical cord and then known as the umbilical arteries. Okay, this is what we are talking about. How the placenta makes the hypogastric arteries, then they become the arteries of the fetal arteries. Then they, of course, they are going to take blood. Okay, this is what we are talking about. Okay, so this is the ductus arteriosus, which is a connection between the two blood vessels here. Okay, then you have the foramen ovale, which is a connection between the two arteries. Then you have the ductus venosus here. Okay, then you have the hypogastric arteries. Okay, then the circuit, so the blood from the placenta is carried to the fetus by the umbilical vein. Less than a third of this enters the fetal ductus venosus and is carried to the inferior vena cava, while the rest enters the liver proper from the inferior border of the liver. Okay, the branch of the umbilical vein that supplies the right lobe of the liver first joins with the portal vein. Then the blood then moves to the right atria of the heart in the fetus. Then there is an opening between the right and the left atria. Okay, then the foramen ovale, between the foramen ovale, of course. Okay, since it's a connection between the right and the left atria, and so on, which will connect them. Okay, that's the opening between the right and the atrium. That's the foramen ovale, and most of the blood flows through this wall directly into the left atria from the right atrium, thus bypassing the pulmonary circulation. Then the continuation of this blood flow is into the left ventricle, and from there it is pumped through the aorta into the. So this is what we are talking about. So of course, blood will come from the placenta. Okay, it goes to the umbilical vein. Then some will bypass the is to follow the ductus venosus. Then some of course to go to the liver and they'll come here. But the one who goes straight from the ductus venosus goes directly or is shunted to the vital vena cava. Then it goes into the right atrium. But remember, there's a connection between the right atrium and the left atrium, which is the foramen ovale. So blood will flow from the right atrium through the foramen ovale to the left atrium. Then once it goes to the left atrium, it will go to the left ventricle. Okay, then the one which went to the right ventricle is going to pass through the pulmonary trunks, go to the lungs, and again pass through the pulmonary veins. Then the one which passes through the ductus arteriosus also, they are all going to meet at the aorta. Then they will give systemic circulation and to the umbilical arteries and back to the placenta. This is what we are talking about. Then some of the blood moves from the aorta through the internal iliac arteries to the umbilical arteries and re-enter the placenta, where carbon dioxide and other waste products from the fetus are taken up and enters the maternal circulation. Then some of the blood entering the right atrium does not pass directly to the left atrium through the foramen ovale, but enters the right ventricle and is pumped into the pulmonary artery. Then in the fetus, there is a special connection between the pulmonary artery and the aorta, which is called the ductus arteriosus, which directs most of this blood away from the lungs, which aren't being used for respiration at this point, and the fetus is suspended in amniotic fluid. So this is what we are talking about. And previously, I think we even explained most of this. Okay, and this is the fetal secretion we are talking about. Okay. So oxygenated blood from the placenta enters the right atrium via the inferior vena cava. The ductus venosus shunts oxygenated blood from the placenta away from the semi-functional liver and towards the heart. Okay, this is what we're talking about. Then blood arrives via the uh, umbilical veins. The near the foramen ovary allows oxygenated blood in the right atrium to reach the left atrium. To the left atrium. Then the ductus arteriosus connects the aorta, which the pulmonary artery, further shunting blood away from the lungs and into the aorta. Then mixed blood actually travels to the head and body and back to the placenta via the aorta. So this is the fit. Then flow. Okay, so the blood flow through the umbilical vein is approximately 35 ml per minute at 20 weeks and 240 ml per minute at 40 weeks gestation. This is adapted to the weight of the fetus. This corresponds to 115 ml per minute per kg at 20 weeks and 64 ml per minute per kg at 40 weeks. It corresponds to 17% of the combined cardiac output of the fetus at 10 weeks and 33% at 20 weeks of gestation. Then of the endothelin and the prostanoids will cause vasoconstriction in the placental arteries, while nitric acid causes vasodilation on the other hand. There is no neurovascular regulation, and catecholamines have only lead to effects. Burst of pathway of oxygenated blood from the placenta through the umbilical vein goes to the uh, it goes to the it goes after it goes to the fetus. So this is supposed to be like this. So the fetus, it goes to the liver, and from the liver is going to receive oxygenated blood from the portal vein and through the ductus venosus, and from the ductus venosus is going to go to the inferior vena cava, then from there pass through the right atrium of the heart to the foramen ovale, then to go from the left atrium to the left ventricle. That's the thing we are talking. Okay. Then during ventricular systole, okay, so during ventricular contraction, on the left ventricle, the left ventricle blood pumped to the ascending aorta and distributed by their branches to the heart, which is the head and neck and the brain and the arms. Then to the right, so this is the right side, the right ventricle blood with oxygen with less oxygen content is discharged via the pulmonary arteries through the ductus arteriosus to the descending aorta, which goes to the epigastric artery, then it goes into the umbilical arteries, then finally reaches the placenta. Okay. The thing which is the blood pressure. So it is the fetal heart, not the mother's heart, that builds up the fetal blood pressure, that drives its blood through the fetal secretion. We have intracardiac pressure, which remains identical between the right and the left ventricle of the human fetus. Then the blood pressure in the fetal aorta is approximately 30 millimeters of mercury at 20 weeks gestation and increases to somewhere 45 millimeters of mercury at 40 weeks of gestation. Okay, then the fetal pulse pressure is somewhere 20 millimeters of mercury at 20 weeks of gestation, increasing to 30 millimeters of mercury at 40 weeks gestation. Okay, then we have the blood pressure which decreases when passing through the placenta. So in the arteria umbilicalis, it is again approximately somewhere 50 millimeters of mercury, and it falls to 30 millimeters of mercury in the capillaries of the villi. Subsequently, the pressure is 20 millimeters of mercury in the umbilical vein, retaining to the heart. This is what we are talking about, the cardiac output during the fetal life, 350 ml per kg per minute. Then following birth, 500 ml per kg per minute. Then the heart rate goes from 120 to 140 per minute. Another teachers will tell you 120 to 160 per minute. Birth, clamping there are called shuts down low pressure system, when there is increased atmospheric pressure, which of course again there is increased vascular resistance, causes lungs to inflate with the oxygen, and of course this is where even the child actually gives a cry. Okay, then the lungs now become a low pressure system. So what are some of the changes in the fetal secretion after birth? So in terms of the shunts, the ductus heterosus, which is functional closure, is 10 to 96 hours after birth. Anatomical closure is 2 to 3 weeks after birth. The remnant is the ligamentum arteriosum. Then the foramen ovale is functional within the several minutes after birth. Then anatomical closure is 1 year after birth. Then the remnant is the fossa ovalis. Then the ductus of venosus and functional closure is within several minutes after birth. Then the anatomical closure is 3 to 7 days after birth. Then the remnant is ligamentum venosus. The umbilical arteries go to the umbilical, change to umbilical ligaments, umbilical vein change to ligamentum teres. So that's what happens. Then these are some of the changes from the differences between fetal and the infant circulation. In terms of pressure, in the fetus, it's low pressure system. As for the infant, is high pressure system. The shunting is the right to left shunting. Also in the infant, it's the left to right blood flow. Then the functions of the lung, find that in the fetus the lungs are non-functional, whilst in the fetus the lungs are functional. Then in the fetus there is increased pulmonary resistance, whilst in the infant there is decreased pulmonary resistance. In the fetus there is decreased systemic resistance, in the infant there is increased systemic resistance. Okay? So the changes in secretion which occur are not due to tying of the umbilical cord, but rather to establishment of respiration. So when the infant cries, the lungs expand and their vesicular field is increased. So the blood which has been passing through the ductus heterosus to the aorta now flows through the pulmonary arteries to the lungs for oxygenation. So within a short period from 5 to 20 minutes, the ductus heterosus closes and eventually becomes a cardiac ligament. Then in a very small number of cases, the ductus heterosus remains patent, which we start calling the patent ductus heterosus or PDA, which is one of the congenital heart diseases. Okay, then the increased flow of blood to the lungs reduces the pressure in the right side of the heart and increases the tension in the left side, causing the valve-like foramen ovale to close. If this does not occur, then the venous blood in the right atrium will mix with the arterial blood in the left atrium of the heart. Then the part of the umbilical veins lying under the abdominal wall becomes thrombosed and occluded soon after the cord is tied and forms a fibrous cord. Then the ligamentum teres of the liver, which is the ductus venosus, becomes ligamentum venosum, which supports the attachment of the portal vein to the inferior vena cava. Then we have the hypogastric arteries which atrophy and form a ligament between the bladder and the umbilical. Going to happen, then that's the end of the talk. Please subscribe and get the notification. And see you on the next tour. That's the end of the cardiovascular.